Hello everyone, myself Mr. Kiran S. Chinswalkar, lecturer in Mechanical Engineering Department from Praveen Patil College of Diploma Engineering and Technology. Today we start third chapter, that is casting processes and plastic molding, part 1. In this slide we study learning outcome. After watching this video, you will able to know what is working principle of casting, second, basic steps in making sand casting, and third, material used for pattern. Now we see introduction to casting. Casting may be defined as a metal object obtained by allowing molten metal to solidify in a mold. The shape of the object being determined by the shape of the mold cavity. Now we see working principle of casting. First point, in casting, the metal is melted, then poured into previously made mold or cavity which conform to the shape of the desired component. Second point, after this, molten metal is allowed to cool in a mold and then it is removed and cleaned. Point number 3, parts of intricate shape can be produced by casting. All the metals and some plastic can be cast. In this slide, we study what is the different advantage of casting. First advantage is it is most versatile manufacturing processes. Second, intricate shape components which are difficult to produce by other method can be manufactured easily by casting. Third advantage, very complicated shape can be cast in a one piece. Fourth advantage, metal like cast iron which is difficult to shape can be given shape by casting easily. Point number 5, mass production of component is possible. Point number 6, very heavy and bulky component can be cast easily. Point number 7, overall cost of component is low. These are some advantages of the casting. Now we see choice of casting method depends on first, rate of production, second, surface finish required, and third, dimensional accuracy required. Then we study types of casting. Casting can be made by the following different types. First is a sand casting, second is a shell molding, third is a investment or lost wax processes, fourth is a die casting processes, fifth is a centrifugal casting, sixth is a vacuum casting, and seven is a continuous casting. These are some types of casting. Now we see basic steps in making sand casting. 6 basic steps in making sand casting. These are, first is obtaining the casting geometry, second is pattern making, third is core making, fourth is molding, fifth is melting and pouring, and sixth is clearing. Now there is a brief explanation of casting processes is as follows. First step is obtaining the casting geometry. Point number 1, the traditional method of obtaining the casting geometry is by sending blueprint drawing to the foundry. Second point, this is usually done during the request for quotation processes. Point number 3, however, more and more customers and foundries are exchanging part geometry via the exchange of computer aided design file. Second step, Second step is a pattern making. First point, the pattern is a physical model of the casting used to make the mold. Second point, the mold is made by packing some readily formed aggregated material such as molding sand around the pattern. Point number 3, when the pattern is withdrawn, its imprint provides the mold cavity, which is ultimately filled with the metal to become the casting. Point number 4, if the casting is to be hollow, as in case of pipe fittings, additional patterns referred to as cores and are used to form these cavities. Third step is a core making. Cores are forms usually made of sand which are placed into a mold cavity to form the interior surface of the casting. Point number 2. Thus, the void space between the cores and mold cavity surface is what eventually becomes the casting. Fourth step is molding. First point in a molding is molding consists of all operation necessary to prepare a mold for receiving molten metal. Second point, molding usually involves placing a molding aggregate around a pattern held with a supporting frame, withdrawing the pattern to leave the mold cavity, setting the cores in the mold cavity, and finishing and closing the mold. Fifth step is melting and pouring. The preparation of molten metal for casting is referred to simply as melting. Second point, melting is usually done in a specially designed area of the foundry, and the molten metal is transferred to the pouring area where the molds are filled. Sixth step is cleaning. First point, cleaning refers to all operation necessary to remove sand, scale and excess metal from the casting. Second point, the casting is separated from the mold and transferred to the cleaning department. Point number 3, burn on sand and scale are removed to improve the surface appearance of the casting. Point number 4, excess metal in the form of fins, wires, parting lines fins and gates is removed. Point number 5, casting may be upgraded by welding or other procedure. Inspection of casting for defects are generally qualities performed. Now we see the what is pattern. First point, pattern is a model of article of desired casting. Second point, pattern is required to prepare a mold. Third point, the mold is made by packing suitable molding material such as molding sand around the pattern. Fourth point, when the pattern is withdrawn, it forms a cavity or impression of the article in the sand called mold, in which molten metal is poured and allowed to solidify to give us desired casting of the shape of the article. In this slide we see material used for pattern. In this first point is pattern can be made of any material which will retain exact outline for a required number of mold. Second point, the pattern should be strong to withstand ramming, wrapping and abrasive action of sand. Point number 3, it should have well finished surface to give a clear casting. It should not be affected by moisture. Point number 4, patterns are generally prepared from wood, metal, plaster of Paris and plastic or wax. Now we see different material used for pattern. First is a wood. First point, for small number of casting, wooden patterns are used. Point number 2, wood used for pattern should be well seasoned and should not wrap or shrink. Straight grain, free from knots, easy to work, strong and reasonable in cost. Different types of wood used for patterns are: first is a white pine, second is a mahogany, third is a maple, beech and cherry. These types of wood are used for the wooden pattern. Now see advantage of wooden pattern. Okay, advantage of wood as pattern material. First is it is readily available. Second, it can be easily cut and formed in a desired shape. Third, only by placing and sanding a good surface finish can be obtained. Point number 4, applying preservatives like shellac, varnish, etc. It can be preserved for long time. Point number 5, it's light in weight. Next point, disadvantages of wood as pattern material. First point, it is affected by moisture when it comes in a contact with the damp molding sand. Second point, because of sand abrasion, it's wear out quickly. Point number 3, its life is short. Second material which are used for the making patterns is metal. Metal patterns are used for mass production work. Commonly used material for patterns are cast iron, brass, aluminum alloy, magnesium alloy and white metal. Now we see advantage of metal as pattern material. First advantage is it has long life as compared to wooden pattern. Point number 2, no change in shape with moist sand. Point number 3, when stored, dimensional accuracy. Point number 4, resistant to wear. Point number 5, better surface finish. Now we see disadvantages of metal as a pattern. First point is it is a costlier than wooden pattern. Second, machining is costly. And third, heavier than wooden. No warping occurs. Now we see third material for pattern is plastic. Advantage of plastic as a pattern material. First, it is strong and dimensionally stable. Second, it has glossy and smooth surface finish. Point number 3, it does not absorb moisture. Point number 4, it is light in weight. Point number 5, it has high resistance to corrosion. Point number 6, it has low solid shrinkage. Point number 7, it is comparatively cheap. These are some advantages of plastic as a pattern material. Now we see next material is plaster of Paris. First point, it is also known as gypsum plaster. Second point, it is used for making patterns and core boxes of small in size and having intricate shape. Third, it has high compressive strength and it can be easily worked with the wooden tools. Next material used for patterns is wax. Wax patterns are excellent for investment or lost wax casting. Second point, they are prepared by injecting liquid or semi-liquid wax into a split die. Point number 3, the die is of split type and water cooled. After cooling, the die parts are separated and wax pattern is taken out. I hope you understand this presentation. Thank you.